Hi everyone, very good afternoon to you all. I hope you all can hear me. If you can hear me, please raise your hands. You would have the tools in your on your desktops. One request I have is to mute your desktops and workstations because I can hear a lot of background noise. Thank you, Rajni, Renan, and Sanjyoti. I have seen your hands raised. So we have about 19 participants as of now. The count is increasing. Please raise your hands if you can hear me. Okay, so most of you can hear me now. So see, this is going to be a session on introduction to big data. And I again request you to pause, mute your workstations because I can hear a lot of voice, background voice. Okay, so see, we are going to get started with the introduction to big data, and I welcome you all in this training. Let me first of all do a small quick poll. Okay, so since you have this tool bar on your screen, I'm going to launch a tool a poll, and would like to ask you how many of you have worked on Linux or big data. So just in a while, I'm going to launch the poll. Okay, the poll is on your screen. All you need to do is just uh, give an answer to that. So we have 45% votes as of now. 75% over. Please respond to this vote. Yes to the poll. Yes, so we have 50% out of 80% who have voted. 50% say they have worked. So that's a good response to know from all of you that most of you are familiar with Linux operating system. Okay, so now we have about 81% votes on this poll. I'm also going to do a next poll consequently, and this is going to be on your expectations from this particular training. Okay, so we have a 50-50 response out there. Well, that's good to know that those of you who have in fact got some experience on Linux, it's a nice thing to have. Whereas those who haven't got the experience, then this can be as a knowledge enhancing experience for them. So thanks for your calls. Okay, thanks for your responses. I'm also going to launch another poll, which is your expectations from this training. So please also have a look at this and respond to it. Okay. we have about 78% votes, and what I see is about 24 people have arrived in the webinar as of now. So let others also join in. However, I will be telling you what we are going to see and discuss in this. Although it's a one-time or one-way interaction, however, you can always respond back to me in a chat window. So I would first like to tell you that there is a chat window available for this, and you can always send your queries, concerns, and any question whatsoever. You can absolutely put that across to me. So in the poll, I've found that 26% of you, I would rather like to share this window so that you can also have a look at it. So approximately 30% are more interested for the knowledge enhancement. 5% say that it is just required for the job, and 65% are for the skill enhancement. So well, thanks for this. Thanks again. So I would admire that you have come here for knowledge enhancement and skill enhancement, and please ask me any questions whatsoever in your chat windows. So I'll just show you where the chat window is. Can you all see the chat window? I'm just checking on. Raise your hands if you have the chat window. So you can always, send me. I'm just sending off a message. So yeah, I can see a couple of you who are sending a message. So for example, I see a message from Renan, then Neelkantha. So welcome everyone. Okay, we have a session till 6 o'clock today, and I'm sure that if you hear this out and go through this session on big data, you would be uh, surely have attained a lot of knowledge. Okay, and of course, because the IT industry is all skill based as well as hands-on based, even if you attain an age of maybe 30 years or 40 years, your hands-on skills are absolutely always preferable. So let's get started. All right, let's have a quick poll. Let me hear from you, either by either you can raise your hands or on the chat window, whether we can get started. So okay, let's then continue with our presentation. Can you all see the presentation screen, which is showing introduction to big data? And then I'm going to start off with the presentation. So one thing I would like to tell you is that besides the presentation, I have also shared a number of items with you all. Okay, these includes the PDFs. There is a YouTube link and a couple of documents. Okay, that are there for you. You can absolutely go to this day one. Okay, and within this you will find that there is a couple of documents that have been shared. So as and when we go to we reach those points where we can yes. So we see a couple of. Whenever you have a doubt, please send me in the chat window. I think that's the best thing I would say, because chat is very interactive, and I will be able to see who has sent what. So I'm going to start with the presentation. Do raise your hands or do tell me in your chat if you're not able to see this presentation, right? So let's get started. I welcome you all again and wish you all the best even in advance. So see, this is introduction to big data, and uh, although big data has been there as a buzzword since long, uh, it hit the word itself was coined back in 1999 in a sort of informal meeting by EMC and companies, then, and the word itself was coined in the way that the presenter was saying that we are entering an era where big data will be a very common thing. Um, so this is not Mithun, okay? This is Manish Chopra here. I've also, I think, uploaded some this particular presentation, or I will be telling you my SlideShare handle from where you can get most of the PDFs and PPTs. So if you still want the SlideShare handle, just it's although there at the end of this particular PDF. So let me just copy the SlideShare and then put it across. So see, this is the SlideShare handle. So well, Mithun is the organizer for this particular demonstration. Okay, so I'll just be giving you my SlideShare. Give me a moment then, just in case if you are looking for the SlideShare, just be giving that in the chat window. Okay, I have just, oops. Okay, I'm just putting the SlideShare link in the window, just in case you are interested to, go through the several slides, including this one. So anyhow, after the presentation, I'll be sharing with you this particular slide, and let's look at the presentation agenda. Besides this, I have also shared with you all the content that we are going to see in these 4 hours. And if you go to the the training share, okay, you would be able to see there is a PDF. Let me just show you which PDF it is, so that you can refer to that one. So I think that I have not yet shared. Let me just check once again. If it is not there, I will be putting that. So this PDF is called as Introduction to Big Data. I'm uploading that. And let me know if you all can view the files that have been shared for this training. Because I cannot hear you, I would like to see that in the chat window. Okay, so if it is the poll window for you, then you need to close it. Close the, I could not see your screen, so unable to see the screen. Okay, so let me just see why the screen sharing is, well, screen sharing is pretty much up. Let me see if the screen sharing is not happening. Okay, I'm looking at it. If you are not able to see my screen, I'll just have a look at it. Give me a moment so that I can see to your queries. I can see the screen, it is still the quick polls. So I think you need to close the poll. Okay, so let's see. Okay, I'm closing the poll now. 40% for knowledge and 50% for skill enhancement. Let's see if you can see the screen again. Yeah. So I believe now you can see the screen. Yes. Okay. Thank you. Great. All right. Now, the other thing I wanted to tell you was the shares that I have done, okay, which the files that you can download. So you need to go in the training itself, okay, and see if you can download that. Now, see, this is the agenda. The agenda I am referring to are the course topics here. So we will start with understanding big data and Linux as a prerequisite for big data. Then understanding the Linux command line. Then we have introduction to big data technologies and the 3 V's of big data: structured and unstructured data, centralized and distributed computing, and finally the distributed file systems. So we'll get started from the PPT that we had open, okay, and I'll get back to the same application, and let's go for the full view now. Will that be fine? Yeah. Yes. No. Maybe. So now we are going to get started with this, okay, and let's at least go 25% through into this, and then if you have any questions, absolutely, so you can ask your questions. Now, as I said, that big data is already about 3 to 4 years old, at least the technology, so we should be apt with this. Now, it's the same scenario that we had with the cloud as well. For cloud, which started back somewhere around 2005, 2007. That's the time when we used to hear, that the cloud has started. And then in these years, let's say the last 5 years, companies like, VMware and Amazon, Google, they have come up with these innovative, offerings, the cloud offerings. So the same scenario also happens to be on big data itself. So I see many of you are referring to me as Mithun. This is Manish here. And so the same scenario is very much for big data as well. And you would be surprised to know that many companies have had a lot of maturity into big data technologies, and they are really moving ahead. I'm sure you would have also come across the word Hadoop, which is, as per my understanding, only about 5 to 10% of the entire big data arena. So Hadoop is very, very limited, okay, whereas big data is actually a very large concept. So let's move on. What is big data? Who is it for? Okay, and why big data? And how to get started and when? Okay, and objectives and benefits. These we are going to see in this presentation itself. So you can absolutely ask me any questions in this. No, I cannot hear your voice because I have to mute all of you, because if I happen to hear you all, then most of you would be speaking, at the same time. So I cannot really hear you. Okay, so that's the concern. Now, data is in fact of paramount importance. Earlier, we used to, go see gold as highly valuable because gold mining was done and gold has a lot of value. But even more so these days, data being there everywhere. Okay, it's there on the internet. It is there in each of the companies, data centers, and then personal data. So with this explosion of data, okay, data mining happens to be the new, or it was a new word. Okay, and data is the new gold. This is what was stated, that data is the new gold, and then you have large scale data management based on that. See, Google is one of the examples. But as we go through this particular course, we'll see that everyone cannot become Google, right? Everyone can't really become Google. And so for that reason, each company can go for a limited data management capability, okay, as per its own capability or its customers. So data, that is how becomes very, very important uh, term, okay, so that we can actually do a lot of mining, managing very large amounts of data and extracting value from that. And then if somebody asks you what is big data, so there is no single definition for it. If you even refer to Wikipedia, uh, when we look at companies like Google, Yahoo of course was taken by Verizon, I believe, and then Facebook, all the big giants, they happen to have some or the other big data uh, establishment. Okay, we can have a data center of, let's say, something 100 machines or even 10 machines, server machines. Each of them are churning the data most of the time. Whereas when we put a specific term, this specific term big data, it will be definitely different from the traditional kind of computing. So that we will soon see how big data is different from the traditional model. Now the data generation, when you look at, I hope all of you are able to see the screen. You may just raise your hands or tell me on the chat window anything. Okay. Okay. Thank you. Thank you. Okay. So most of all of you can at least see the screen. So the data generation happens to be web-based. Okay. E-commerce. There are different department stores, grocery stores. So everywhere the data is being generated. I mean, if you go for an airline reservation or train reservation, banks, credit cards, every time you do a credit card transaction, there is generation of data. Social networks. Okay, yes, you can certainly get the PPT. In fact, since I have mentioned the slide share, if you just refer to my chat, okay, this very same PPT is also available on my slide share and is downloadable also there. So have it downloaded from there, okay. And secondly, there are a number of uh, material that I have shared for this training. Let me know, have you downloaded that? You can raise your hands, tell me on the chat. Okay, great. Okay, so most of you have in fact downloaded that. And see, I have shared that precisely so that you can get started with the big data uh, technology on your workstations, on your laptops. So let me know, have how many of you have worked with the VMware? I would like to make a poll for that, but you can raise your hands or tell me on the chat, how many have you of you have worked on the VMware workstation, just workstation. So I can see only a few hands, something like maybe, yeah, well, most of you. So if you have VMware workstation, okay, and you have Linux, then you can jump into big data technologies within one day, I would say. Thank you, Praveen. I can see your chat. So if you are aware of Linux, then you can absolutely get started. So later on, I will be telling you about the Cloudera virtual machine, okay, from which you can get started in no time. In no time, absolutely. I'll be demonstrating that also, so that maybe, yeah, today itself we will have a look at the Cloudera virtual machine. You can download that and get started with your own, big data development. Now, moving on with these healthcare records, okay, satellite imagery. So recently I have been associated with the ISRO participants and found that the satellite imagery, processing and weather modeling, okay, has to happen because that's a different kind of data. Okay, so later we will see what are the different data types. Okay, and finally in public domain. So these are the different places, and I would say this is just limited. This is just a fraction of uh, the sources of big data. Now, data explosion has happened immensely in the past. From this diagram, you can absolutely see, how the data explosion has happened, right? And if you look at the bottommost layer, which is business process database, that was OLTP database. So what is OLTP? Let me ask you, what is OLTP here? No answers yet. OLTP? Still no answers. The full form of OLTP? Yeah, absolutely. So that was fantastic, Ramakrishna. Thanks for that. Online transaction processing. And also from Manjunath. So see, all the databases, whether we have Oracle, MySQL, Sybase, DB2, which from IBM, Microsoft SQL Server, these are all transaction processing databases. After this, there is human generated content, which is emails, weblogs, documents, social media. And if we look at the email also, there is email analytics, a lot of email analytics going on these days. So most of the companies, for example, they have email analytics, being processed. For example, even Google does it. Any uh, any data that any text that we are sending, which is not very human or which is not appropriate, then that actually can be, you know, isolated through email analytics. So then documents and then even weblogs. So these are other text-based stuff. However, we will see later there is unstructured data also, um, like video data, sensors, satellite imagery. These are the different type of data, and I have mentioned, I have shared one link for Google Content ID. If you may refer to Content ID, okay, which is a Google patented technology. I'm writing down on the chat window for your reference. This happens to be a Google's patented technology. Now what happens? You can actually see the YouTube video link which I have shared in the materials. What Google does is to basically every time you are uploading any video on YouTube, Google matches each and every frame, okay, which with the video that you are uploading, because videos are in frames per second, so mainly the 30 fps. So the database that Google already has, okay, of the videos are of maybe of copyright owners. Let's say a Hollywood movie maker tells Google that any of the movies should not be uploaded on YouTube. So let's say if one is trying to upload a Hollywood movie, okay, which is, let's say, pirated or something, each and every of that frame, that gets uploaded to YouTube is matched with that of all what is already available in Google's database. So once even one frame matches, then that is sent across to the Hollywood movie maker, saying that okay, this is this is a pirated video which is being uploaded. And so what Google does is Google will at that very moment uh, block this particular video getting uploaded, and as well as the person's handle. So your account is basically blocked by Google. I hope you have got this concept. Let me know on the chat window or by your hands. Okay, so I've got 2-3 answers in the chat window. Okay, so Google Content ID, have a look at that. It is one of the best methods, or one of the best use cases, real examples that we have for unstructured data processing. Okay, so this is typically unstructured data processing. Okay, so that was the data explosion, and now we move on to the data approximation. We'll look at the scale of data, okay, which is there already, and the pace of data that is being generated. So scale and pace of data is what we see from this slide. The first one here is a 2008 figure, okay, which is Google processing 20 petabytes per day, and then Facebook, Wayback, eBay, and CERN, each processing almost a similar figure, okay. Depends, but they are definitely processing huge amounts of data. The same I have seen for many companies, that they happen to uh, uh, ingest a lot of data every day. So that is how these are the 3 characteristics that we will see of big data. Okay, so one is scale. As you have seen, that so much 44% or times increase from 2009 to 2020. That is an estimated figure. So at the individual level, we go on clicking photos and videos. We have individual files. For corporates, there is immense amount of data. Okay, so all this is adding on to the data explosion. So the scale is one of the factors of big data. Complexity happens to be the other. So for complexity wise, we would say the different formats. Okay, as I just said that video is one format, you have text as another, okay, and then different data types. So even in text itself, we'll have to segregate that into different types. So these are the different types of, you have text, numerical, images, audio, video, sequences. Okay, so sequence is one of those genome sequences we are talking of, right? So medical data, then social media, okay, multi-dimensional arrays, and so forth. So data types are immense. I mean, it only depends on the number of applications that we are making. So if the number of applications are more, then we can also go on to correlating the data among different applications. That's what actually happens. So moving on from here, the speed of data, isn't it? So this is the third characteristic, that is the pace of data at which it is being moved, right? So you have online data analytics, okay, because for web servers like companies like Facebook, Flipkart, even Amazon, there are servers running behind, and on the servers we have some or the other analytics for each and every user who comes to just browse the pages, or who goes on to log in and then selects some products from there. So those analytics are absolutely ongoing, and today we have a number of analytic solutions these days. Okay, so can you tell me some type of analytic solutions? I'm only looking at something like big data analytics, business analytics. What are the category of analytic solutions already in place? You can type in the chat window. So SSAS, yeah, that is in Microsoft. Uh, any other? So SSRS, yeah, that's again Microsoft. So see, these days we have real-time analytics. Okay, so real-time, that is one category. Then you have business analytics. Then, as I said, big data analytics is already, yeah, so big data analytics is already there. Any other that you can think of? Email analytics is the another one that I told you, isn't it? So there are different types of analytics that are, starting to appear on the horizon because of the need. So every time, even if you look at the Wikipedia page, you will find different. Now, cognitive analytics is another. Okay, yes, Google. So yes, that comes under web analytics. I've got a response from Shrikant saying Twitter and Google. Absolutely, that can a lot come under web analytics. So there are number of analytic solutions that have appeared on the horizon, and companies are working towards it. So having a look at the three V's again, when we look at this image, okay, you will find that on the left hand side, okay, we have ERP solutions, which we used to talk back in late 1990s, 99, 2000. We used to talk about ERP, and then shortly after that came the CRM, customer relationship management. They were mostly web-based and database based solutions. Then came web-based solutions. Now up till then there was nothing like IRCTC where we do the train reservation, isn't it? So when the next graph over here is the web-based solutions came. So companies and people started going online. So this was post 2000, and now we have had big data, wherein the maturity has already happened in a lot many segments. For example, sentiment analysis. So if you are interested in knowing more on sentiment analysis, then we have already, there are open source solutions available for sentiment analysis and user click stream, and quite many of them. And apart from that, we have the other types, okay, which you can see on the right hand side. So this is where we are moving on to the big data solutions. So another similar one we have after this is the fourth V. Okay, so the fourth V happens to be veracity. Now, apart from all the data that you have, okay, there is some data that is still in doubt. Now, the data in doubt happens to be something that is not verified yet. So possibly if somebody is writing on, say, Twitter or on some other social media, it is not necessarily verified. The person has just written, but we cannot verify whether that information is true or not. So uncertainty due to data inconsistency or completeness. And the same goes for when we are doing large database joins. Okay, so that was one example. When you're doing large database joins, let's say we have two separate databases where we have to do a join. So that is also a situation when data in doubt can occur. Let me know how many of you know about database joins. I have just written in the chat window. Okay. Don't know. Neelkant says don't know. Okay. Okay. Radhe Thakur says yes about joins. So database joins. Anyhow, you can, those who are not very aware, uh, and those who are not into the database field. Now, let me just tell you that those of you who are, fresh into your jobs, or even those who are 2-3 years experienced or maybe 5 years experienced, we are usually, concerned with our field. So for example, those who do not know about joins probably are not working in a DBA field or a database field. So it is not necessary that you have to know about databases and about joins to go ahead into big data technology and a big data project. You may be good at programming. Okay, so if you're good at programming and writing logic, you don't absolutely have to know about anything about joins. So I would again say that those who are into DBA kind of roles, database experts, yes, they have a specific field, to work in big data. So we'll move to NoSQL databases and other databases, and those are the technologies that DBAs should attempt to understand more. So who is big data for? Okay, so the four pillars of any organization. Okay, as we have business, then infrastructure, then you have the data. Okay, and then finally we start creating applications. So based on this, big data applies to specifically to specific people. So it's not that if you know, as I said earlier, that if I don't know a lot of C programming or scientific programming, then I can switch to another field, because as and when the technology moves, we have to adapt with it. So if you are not adapting to the present day technologies, then we are going to be left behind somewhere, right? Okay, guys, let me know if you need a small break. So I'll pause for some time, okay, and then we can maybe start in 5 minutes once again. Do you need the breaks for 5 minutes? No. Okay, so no breaks yet, at least. Okay, that's good enough. So now I'm moving on into harnessing big data, right? So how the companies have been harnessing, big data. So again, it depends whether it is a small company, okay, or a very large company. Large companies are definitely moving on to, train their people to, have their employees do the certifications on big data or some other technology, and then they move on into working on some of the other applications. So previously we used to have OLTP, as you can see over here, okay, and we have seen earlier also. Then came OLAP. Now, if you are not aware of data warehousing, I would rather like to tell you that there are data warehousing and data mining applications from almost every company. Let me write that to you. So we have SAP BI. I'm writing that on the chat window. We have Microsoft BI. We have IBM BI. So IBM Cognos is the IBM BI is Cognos. Okay. Then we have OBI is Oracle BI. So something that I've just written on the chat window happens to be the competitive offerings, from all the big giants. So you have SAP Business Intelligence, MS, Microsoft, IBM BI, Oracle BI, and in fact the list goes on, right? So it is not restricted to only these giants offering their business intelligence solutions. Okay, so which is also associated with the data warehousing. So let's take example of Oracle BI. Okay, so Oracle BI, the prerequisite is Oracle database. So you need to first have Oracle database set up, and then a Oracle business intelligence application will be established over it, right? So after all these, we now have the real-time analytics processing. So those happen to be the big data solutions. I hope this is understood. Okay. All right. All right. So going with that, the previous model was your uh, many to one kind of a model. If you've done the database modeling, you would find many to one. So in this screen, you will see that it was many, okay, many people, okay, and to one. And then you have the new model, all of us are generating data and all of us are consuming data. So that is a many to many model, something that we can see from Facebook and Amazon kind of a, Flipkart and Amazon. Now, big data doesn't only, apply to Flipkart or Amazon. Why? Because even though they being the resellers or sellers of online products, they are just the intermediary. They're just online marketplace. So being online marketplace, all you have to do is just go there online and select your product of choice and get it shipped to your home. So that is just one of the small examples of what big data solutions can bring forth. So looking at the modern data types, have a look at what all modern data types can be there. Yeah. So see, these are the different uh, data types that are possible. So this clickstream data. What is clickstream? Basically, every time we are moving this mouse pointer, I'm sure you can see my mouse pointer, being moved, and uh, the server part of your solution, okay, which is on the server side, we can place equivalent JavaScript code or any Python equivalent code which can track the mouse pointers of the users. Okay, so there are specific solutions that have been developed for clickstream data. Twitter feeds. So Twitter is a very popular application, as well as social media, where people are there. Facebook, web content. Okay, so these are the social media and web. The machine to machine, there's a lot of machine M2M data generated. So sensors and RFID readings. So RFID, I'm sure you would be knowing, is radio frequency identification. Every time you go to a store, or even in some factories, uh, the warehouses are actually having RFID tags on that. So if, let's say, a bunch of 10 boxes, okay, let's say boxes of say shoes or clothes are moving away from a factory, that RFID tag will automatically generate through a magnetic sensor. So oil rig sensors, GPS signals, these are all M2M, machine to machine. And to go by the present trends, if you see companies, they are tweeting big on about automation and artificial intelligence these days. Automation and artificial intelligence uh, are becoming the new trends. And absolutely, big data analytics, IoT, these kind of technologies are all going to be part of us. So we have to be adapt to these. Okay. Then big data, big transaction data. So these are the those kinds, utility bills, okay, and telecom call data records. So all the telecom companies also are, having their solutions made on big data. So facial recognition on biometrics, genetics. So most of the healthcare, industry is for this. Then you have human generated data. So that are the data types. Now there have been challenges in handling big data. Um, on the right hand side, you would find the kind of poll. Okay, so this is kind of a poll, and have a look at this. What do you see is the biggest challenge in big data? Biggest challenge? So you are raising the hands. Software? Yep. Lack of software tech. Yeah. So see, lack of software is obviously there, but when we proportionately compare it with the people with such skills, you'll find that the analytic skills are actually a problem. Although most of you would find a lot of stuff on GitHub. Okay, uh, I think I have shared one material where I have shared where these are available. So on GitHub, you'll find almost all the projects. So see, the bottleneck always happen to be algorithms, new architecture, techniques, and solutions. So these happen to be. So there are some hands up I can see from Annapurna and from Deepika. So let me know if you have any doubts. You can always ask in the forum, in the chat to me. Yeah. Okay, so the right side is clear to us, okay, and when we look at the left hand side, the data storage growths, okay, the data in 2005 is limited to only few, maybe these are like in petabytes, right, in millions of petabytes. And if you see the curve, see how the curve is going up. So that's in year 2015. So there has been a gap, okay, of technical skills, and we absolutely need more people having big data skills. Now see, this is one of the real scenarios, real figures over here. The scalability factor, okay, how can we process all the information? There are two problems, okay. There is data storage and analysis. So data storage is all right. We can store tons and tons of data, okay, in the sandboxes, storage area networks. You can have so much of data, put there. There's a problem of data analysis as well, right? So data storage is not an issue. But what about the analysis portion of it? So that's what, we are generating more data than ever before, and fortunately the size and cost of the storage has kept the pace. So if you look at these numbers, 1997, about 2 gigabytes costed about $157, and 2014 3000 gigabytes is costing about 0.03. So that has gone to a fraction number. So cost has reduced so much, isn't it? And when we now look at the capacity and performance, so there you will find that in the last 15 years, isn't it? the capacity has increased immensely. If you see these carefully, it was in 97 2 gigabytes, 2014 it's 3000 gigabytes. But the disk read time and the transfer rate, okay, so it is 16 megabytes a second. Now today we have 200 megabytes a second. Now if we start to transfer the entire, entire volume, this 2.1 gigabyte would take about 2 minutes. Whereas the 3000 gigabytes, 3 gigabytes, 3 terabyte will take about 4 hours to transfer. And you would have seen that yourself, that when we have to transfer about 3 terabytes, how long does it take to transfer even from your USB hard drive to your laptop and vice versa. So that transfer rate has still been so less, and that's the reason why we are not storing all the data in the storage area networks these days. I hope you get the concept right. Everything may be put into the storage area networks, but then when the server again requires that large amount of data, consider one disk slice to be of say 3 terabyte itself, okay, on the storage area network, and you put the fastest channel, it is SAS is the channel in the storage area network. You put the fastest channel also, that will also take a lot of time to transfer to the server, right? So that's the reason, and that's a traditional method of using databases, right? So we'll look at the technologies that are in use today, okay, and what is the complexity involved. Now this slide shows us the different players, okay, and different solutions available in the market. Now see, Hadoop is only one of them. Later on you would find that there are a number of other choices available. So those choices will start from what we call as the distributed file system. So distributed file system is still a bit ahead. I hope you are following this. Okay. All right. So good to know. Good to see. You can also raise your hands. I should be able to see your hands. Okay. Then let me ask you something specific. I have most of your hands up. Let me ask you, what would be a distributed file system, or DFS in short? You can also tell me in writing in the chat window. So I see a lot of hands up. I have to manually, okay. So, all right. So sounds good then. Now, so this is your big data landscape, right? On the bottom we have all of the Hadoop ecosystem technologies, and I'll come to Hadoop. Okay, let me see. Some of you are sending some responses. Let me just have a look at the responses. And distributed across different file systems. So Pavan Kumar says, Balaji Jagannathan has answered saying DFS, We have another answer. Data will be saved in multiple servers and accessed, okay, through single path. Great, very nice to know. Files divided in small chunks. Perfect. So separating file based on type. Okay, that's very fine input. I really appreciate that. I wouldn't like to jump straight to the distributed file system, but we'll shortly arrive to the distributed file system. There is another post that I have done on LinkedIn. So that also you can refer on distributed file systems. Okay, this is the most important concept to consider for going on with a big data project. So I'll tell you exactly which all distributed file systems we have, and we'll be shortly coming to that. So there's a lot of stuff to discuss on. So I can't really jump into that. Looking at the left-hand side, you have analytics infrastructure. So you have Hortonworks, Cloudera, Mapper, and Vertica. So Vertica is from HP, all right. And IBM also provides a Hadoop distribution. So I'm just writing on the chat window, Hadoop distributions by, so IBM, it is called as IBM Big Insights. And then you get that from Cloudera is one of the front runners. Then we have Hortonworks. Hortonworks has clubbed with Microsoft, okay, to provide HD Insight. So that's called as HD Insight. That is Microsoft's HD Insight, INSIGHTS. Then we have Mapper. So Mapper comes from Mapper and Reducer, okay, Map Reduce. That's what. And then HP Vertica. HP. We also have Oracles, okay, Oracle, but Oracles is replicated stuff from Cloudera itself. Oracle has a replicated stuff from Red Hat also. So Oracle Linux is the same as Red Hat Linux. So Oracle Hadoop is the same as, I've just put into the chat window, just did a misspell of Oracle. Have a look at these. Okay, so these are the different competition in the Hadoop space. I told you about the competition in business intelligence space, right? Now the same thing has also started off in the Hadoop space. But personally, okay, and professionally, I don't recommend you guys to jump into any one or many of these, okay, just to know more of Hadoop or things. Yeah, for Hadoop, well, Teradata is, again, Teradata is not Hadoop, my dear. Teradata is a different data warehousing technology. So you can have a look at it on some websites. See, Cloudera happens to be my favorite in terms of Hadoop development. Okay, they do a lot of original work, and Cloudera does a lot of innovation. So I think that's enough to tell about this. Hortonworks is the other pioneers of big data. On the second hand here, Couchbase, Teradata, so these happen to be your operational infrastructure. So this is a NoSQL database. Okay, I'm coming to NoSQL a little while after this. Infrastructure as a service, we know Amazon, Azure. Okay, InfoChims is one of the academic ones. Then structured databases, we have again seen all of these happen to be the structural databases. Then when we look at the data providers, there we have some players, okay, as BI, I told you about Oracle BI, SAP, Cognos, okay, and SAS. These are, some of these are new, analytics and visualization tools have been very popular. So Tableau, for example, okay, and Green Plum. So these are some of the tools. So do ask me in the chat whatever your question is. So yeah, it's good to know, which tool does what. If you get to know which tool does what, you can be in the best, position to architect that product. Okay. So these are again some of the tools in the Hadoop space, starting from terabytes and moving into the zettabytes, and the three different, so fast data, big data, okay, analytics, and big deep insight. These are the different type of tools, okay, that have been mentioned uh, in the big data space. So I would just suggest that you should have a good know-how, okay, of what all tools are there. So in the last three slides, we have seen a number of tools. Uh, my suggestion is that you go ahead and see what each tool does, and then suggest it to your group, okay, and then go ahead starting with the project with that. But for all of these, the base is the distributed file system. As many of you have mentioned very rightly, that the distributed file system, uh, the distributed file system, with respect to your answers, okay, you have very rightly said that the, so distributed file system will be a base of any of your project, and we'll shortly look at why, the why part of the DFS, because that is what forms the core of your storage, the distributed storage. So we have another question from Ramakrishna saying, may I know what exactly Hadoop is, and is it like an OS? So well, in short, it is a distributed platform. Hadoop happens to be a distributed platform, and we'll shortly see how you can install Hadoop. I'll be showing you three different virtual machines, and then we will see how exactly from the three virtual machines we can integrate a single file system, okay, as a Hadoop distributed file system. And it all comes from Google, so we'll shortly see to it. Not really. So Pooja is asking, Hadoop is only used for storage purposes? Not really. See, the Facebook's base is Hadoop. Okay, so in the Facebook data centers, let's say there are 1,000, Hadoop uh, servers. Okay, take example your own desktop server. I won't go to Facebook. Okay, take your very own desktop. Okay, accumulate about 10 such desktops. Okay, and in each of the desktops we'll configure Hadoop. Okay, and considering that there is 1 terabyte of space in each of the desktops. So the aggregated space in the 10 desktops will become about 10 terabytes. And then we can, say that, yeah, I have got a 10 terabyte distributed file system. So that is the overall, concept. No voice for 2 to 3 seconds. Well, I'm not getting this concern from everyone. I hope my voice is clear to everyone. If there is any issue with the voice, let me know. I'll take care of it. So moving forward, okay, is how to get started with big data. So you rightly asked, see these questions: how to get started, and what is Hadoop, and how does it work, and all that. So see, big data involves not just tools but numerous technologies. Okay, and believe me, Hadoop is not the only thing that is available in big data. So that is what my advice is to all of you. And we are going to see in this very slideshow itself. So, okay, screen is not available. Let me just look at it. I'm just let me just hold on. I'll just share my screen. Is it visible now? The screen, is it visible? Okay, thank you. So I hope you are not getting any voice disconnections. Okay, fine. So, okay, all right. Okay. So we were at the learning curve, okay, of big data, and so there are multiple things. And as I said earlier, see, there are going to be several fields in big data itself. Okay, just let me take that example of cloud. So now these days we have positions of cloud architect, okay, cloud designer, okay, cloud developer, right? Then within cloud, you see there are several applications uh, available. So Ponraj, okay, one second, let me just. So okay, fine. So let's carry on. Huh? Now, so learning curve again. You can get started according to your skill set, your prior skill sets. Okay, so if you have been into DB activities, I would suggest you go for NoSQL based, skill enhancement. If you have been into, let's say, programming activities, especially Java, and if you want to follow Hadoop, then yes, you can be a Hadoop developer. Yes, but the scope is too much. The scope is immense. Okay, so let's look at it. So algorithms and computing languages are required to practically turn big data into applied intelligence. And so, if a flexible mind starts learning Hadoop, then it can take only a few months. Yeah, Java is enough, or another programming languages. If you want to do Hadoop, then Java is enough. But yes, Hadoop development can also be done using Python, and Hadoop itself has a lot of languages like Hive and Pig. So these are the languages. So for Hadoop, okay, if you want to see do Hadoop, then Java is enough. But let's not restrict over there, okay, because the projects can be large, and then I must say that some of the recent statistics have proven that the Hadoop, some of the Hadoop projects, okay, they say that 70% of the Hadoop projects that started in last 1 to 2 years are actually going to fail. I will tell you how much of an investment it takes if we have to go for a Hadoop project. Okay, so Facebook is all built on Hadoop, for example. But then yes, Facebook also does a lot of other languages. It's not just doing Hadoop, I mean Java or Hadoop. So see, .NET is preferable. All these, I think we can discuss later on. And these are very, very specific questions, right? Whether .NET or Java, they are very, very specific questions. And again, I think you should rise above doing, these languages themselves. So getting started, there are several perceptions and perspectives. Okay, and then there are several tools, right? And when it comes to the tools, okay, the web frameworks also get into, like for example, Google APIs, right? Those kind of APIs. Learn the concept and the platform, right? How big data is managed in a scalable and efficient way. Hadoop can be a good starting point. So this is one very, very interesting line saying, that Hadoop can be a good starting point. If you want to know big data, okay, and distributed concepts, then you can absolutely at least start with Hadoop. Uh, So there are courses, okay, from Cloudera you have admin, developer courses, analyst courses are there, okay, then so many programming languages are there. So we can absolutely look into any of these. Uh, so see, for data science in particular, Python and R languages are preferable. Okay, so I have just replied to you in the chat window for data science in particular. Now, some people restrict the data science only to statistics. So if you are willing to go into a data science role, it's not statistics. It is natural language processing. It is good of algorithms. So a lot of stuff. So one of the use cases I would like to mention is the IBM Watson. So IBM Watson, if you have a look at IBM Watson, it is one of the very success stories of the past. Why? IBM Watson, I'll be very specific over here to tell you. IBM Watson is a hardware firstly, which is running on Power 7 processor, right? It is about 100 servers. IBM Watson is 100 servers. IBM went to a game in US called as Jeopardy. Okay, have you heard of this Jeopardy game? Jeopardy. It is one of the games in US which is equivalent to the Conbade Crorepati game in India, where we get questions from the host and we have to answer, or the other way around. The host will say the answer and you have to frame a question. So IBM said after winning the chess game, we are going to participate in Jeopardy, and they started with this, and they ingested the complete Wikipedia dump. If you want the Wikipedia dump, you can download it. Okay, it's about 40 gigabyte download, and after you uncompress it, it becomes 100 gigabytes. Now think of processing this 100 gigabyte of Wikipedia. That's what IBM did with Hadoop itself. Okay, so it installed Hadoop on the Watson supercomputer and got the Wikipedia dump and even other books from data sources, and then put the algorithms in that and participated in the Jeopardy game. Now Jeopardy, there are two other participants. A total of three participants would play the game and one would win the show. So IBM made it in such a way that they had Watson participate in the Jeopardy game and even won the prize. And won the prize with two other contestants who were the winners of the last 7 to 10 years. So that's how the success story of IBM went. Your voice is breaking. Okay. Well, I'm speaking continuously. That's why probably my voice is breaking. Let me just have some water. Okay. I hope this is clear now. Hold on, let me just okay. So I've just switched to a LAN only network, and hopefully it should not be breaking.
Register the UI for studio or a robot?
Okay, tomorrow meeting is but 4 and 5.
What?
Tomorrow meeting.
Really? You're booking meeting room here?
Then
At 11 to 12.
not 11 to
11 to 12 కూడా చేయగాక please.
Meeting 11:30.
It's okay.
11:30 to 12, no?
Listen, you book later, okay?
10 to 11 also fine, 10 to 12 also
Book the
fine.
meeting room.
Then it's time.
Guys, hi, I
At what
can
time?
hear you now. I can hear you now.
4 to 5. నేను రాక నేను ముందు పోయి.
Are you listening?
3 to 4 also doubt, 2 to 3 you can go.
Hello.
And morning కూడా 1 hour. ఏంది ఇప్పుడు అట్లా చూస్తావు?
So what are you gonna do after going home? You're working there?
Yeah.
So why don't you finish everything tomorrow?
Of course I do work.
Huh?
What do you
No, you're not gonna work. You said me earlier only. You're gonna sit online.
When there is no work,
No,
I said that one, yeah. But there is work.
Yeah.
There is something to learn.
No, I'm asking when you go, are you gonna work?
Yeah, sure.
No, you're not.
That time when I was in UKPN. Now this is Robert. But
guys, it seems that this was the conversation from other participants. All right, so shall we move on then? Let's move on for about 40 minutes. Okay, so I think 4 o'clock we can take a break. Yeah, I've just muted the other attendees. Yeah, it really looks good when you write back. All right. Okay, so now this is a bit of starting with Hadoop. Okay, because this has been my personal experience. Okay, and I have personally been working on Hadoop since about 2012 and 13, and the same you can also start. Okay, and get a hang of it, and that is the reason why I had asked you for your Linux experience. So in order to get started, okay, we only need a Cloudera virtual machine. I'm just sending a small chat. How many have worked? Have you worked on Cloudera CDH VM? So that's my question to you all. Let me know by just yes and no on the chat window itself. Whether you have worked on Cloudera, no. Okay. So have you worked on Cloudera? Reply me by saying yes or no. I have one QTN. Okay, what is QTN here? Oh, you have a question. Yes, go ahead, ask it. Neelkantha, ask it. So Neelkantha, you have also asked about the storage question. So you have asked if I go to storage and server admin, what would be the what are the preferable codes? So see, I have been into Hitachi administration earlier, Hitachi data systems, and I must suggest that IBM, Hitachi data systems, HP storages are the preferred ones. So in case if you are willing to go for storage in particular, you can go for any of these. Raja is saying Linux experience, again Ubuntu knowledge is enough. Yes, it will be enough. Again Ubuntu knowledge, yes. So Ubuntu is more than enough. You can just learn any Linux, okay, whether it be cloud, Red Hat or SUSE, anything. Yeah. So on the slide itself we see RHEL, okay, SUSE. RHEL stands for Red Hat Enterprise Linux. SUSE is from Novell, and the CentOS is, again, it's a community operating system. It is a carbon copy of RHEL, and Ubuntu and Fedora, these are like, again, open source ones. So we can use these Oracle, Java, JDK, Hadoop platform, and the single node, cluster. So see, this particular point, Cloudera VM is one of the quick way of starting. Only any of you can download from the net, and then get it started from there. I'll just mention the link for this Cloudera Quick Start. Give me a minute. So just writing down the link for Cloudera Quick Start. So have a look at the chat window. You will find a link for Cloudera Quick Start, and that's what Cloudera has been doing. Okay, so see, this is the Cloudera Quick Start. Okay, one of the pioneers, and it gives you the CDH. Okay, so the CDH stands for Cloudera Distribution for Hadoop. CDH is Cloudera Distribution for Hadoop. It's mentioned here. Okay, and we can download this. So one of you can download and distribute to your friends and peers. So I've been using from 4 onwards. They've been CDH 3 also. So 4.1, 4.2, 4.4, so and so forth. So I would be rather happy to show this to you, because I think there's nothing without the hands-on. So I'm going to start the Cloudera VM, and would also then share it across in this. So okay, so well, that's a good question. Minimum system requirement is about 4 gigabytes. If you see the same, 4 gigabytes RAM. If you see the same, screen over there, the link that I've shared shows you how much RAM is required for several, of the services. Okay. So that's a good point to start. All right, and I'm just starting my virtual machine, and I'll just share the screen for that. Okay, now see, this is what happens to be the, I hope you can see this. I hope you can see the Cloudera screen. Yeah. Okay, great. Now I'll be doing a couple of demonstrations in this. See, the first thing we have to see is whether we have Hadoop running or not. So we can do Hadoop and say version, right? So it shows the Hadoop version as soon as you do this. And so this is the CDH 4.4. I also have the CDH 5.8 available. And what we can do is just go into, let's say, the hue. Okay. So hue, see, everything is available in the virtual machine itself. So you don't need to download anything extra, okay, apart from the virtual machine. So maybe later on I'll show you what this distributed file system will be. So let's say something like localhost and 50070. Other name note. Okay, now see, this is a typical Cloudera system virtual machine. Okay, and so let me just share the PPT. And we'll be looking at some of the other, How was the Cloudera system screen? Okay, you need to also have the VMware or virtual box prior to having this. Okay, so that is a prerequisite, and we'll anyhow continue to this and see what Hadoop is. All right, a brief introduction to Hadoop. All right, I hope the screen you found, isn't it? And we can start with the brief introduction to Hadoop. Yeah. Okay. Okay. Now, in brief, okay, Hadoop has this. Hadoop was created by a person called as Duck Cutting, as you see here. Okay, and it was the nickname of his son's toy elephant. Now, this has got a lot of history. Okay, when we move back in the mid 2000, like 2005, Google happened to have a lot of data management challenges. So what Google did was to give away the white papers. So the white papers that Google provided, yeah, I know the voice breaks. So see, Google white papers happen to be GFS, MapReduce, and Bigtable. So the three uh, white papers are presented by Google in 2003. So I'm writing the years 2003, 2004, and 2006 respectively. Right. I hope this is clear. So it was the brainchild of Hadoop was the brainchild of Duck Cutting, and Google's published white papers are mentioned in the chat window here. Okay, and so Duck Cutting happens to be the chief architect in Cloudera, and he is also the chairman of the Apache Software Foundation. So that's the history, or that's a description of Duck Cutting. Now this guy is into Java development. Okay, he has been into Java, and he wanted to develop a search engine along with his friend. So he, started off doing that, but then again it was the financial challenges. So he happened to join Yahoo in around 2005. So from 2005 onwards, most of the Yahoo searches, okay, were Hadoop based. So you can think that Hadoop was created in 2005. Okay, the first version of Hadoop, isn't it? First version of Hadoop in 2005 or 6. That's around when we got the first Hadoop version. Now I would like to tell you one more thing on this. That is precisely why Hadoop has gone so popular and none other technologies. So there is a technology called a sector sphere. I would uh, ask you to refer to this on Wikipedia. Sector/sphere. Okay. The main difference between Hadoop and sector sphere was the same. That is the difference between Google and Hadoop. So both Google's GFS and sector sphere are made in C and C++ languages, right? Whereas Hadoop's development happened in Java language. Am I audible? Am I clear to all? Guys? Okay, so those are the white papers that Google, came out. So that's the brief introduction and further explained that GFS, okay, then MapReduce in 2004 and Bigtable, and the same has been re-engineered and reverse engineered by duck cutting. So we have HDFS, which is Hadoop Distributed File System, which is a kind of carbon copy of Google File System. But the difference is GFS has been made in C and C++ languages, whereas HDFS has been made in the Java language. So that's the main difference between these two. And that's what makes the bigger difference, you see. I hope you will understand that bigger difference as and when you move into creating projects further. So Bigtable was the distributed database system, okay, whereas the same was replicated as HBase. HBase is a different project, okay, it's a project that runs on Hadoop. Then coming to I hope this is clear. Let's just be on the same page. Yeah. So I've got 4, 5, 6. Okay, great. So I've got 7 responses from Arun, Krishna, Balaji, Amit, Aman, and Pavan. So that's good to know that I think all right. So this is what is the beginning of Hadoop, you can say, and we can work more on that. Okay, so I'll absolutely give you the directions to go further, okay, on Hadoop development and even other big data technologies development. So the business problem types that Hadoop addresses could be any of these. Okay, risk modeling, customer churn analysis, recommendation engine. So we have some use cases. I can share that with you later on. There are companies who are sharing their use cases that they have made using big data project. Ad targeting, point of sale. Point of sale is where you exactly have the point of sale terminal, isn't it? POS. Threat analysis, data sandbox, search quality, and trade surveillance. These are some of the business problem types, broadly that have been, put. Risk modeling. So anything that we have to do with a large amount of data can be addressed with those problem types. So how does MapReduce help? Now, can you tell me what is MapReduce? Even as we move on, can you explain briefly? Anyone? So MapReduce, what is MapReduce? Framework to process HDFS data. Okay, that's a good answer. MapReduce is a technique to map those data on multiple servers. That's from Pooja. Technique to map those data on multiple servers. So we'll have some clarity on MapReduce. Uh, how does MapReduce help? Common data jobs for MapReduce. See, MapReduce is a computation technique. Now, first, we have to understand what is a distributed file system. Once you understand what is a distributed file system, then we can go into MapReduce. So it is imperative, okay, to know how a distributed file system works. So at this point, I will pause over here and I'll open another text, okay, a tutorial basically, and so we'll just move away into a tutorial which has been shared to you. Now I would, one second. If you refer to setting up a Hadoop cluster in the shared materials, refer to your application, okay, and see where the training material has been there. Let me just show that to you. I hope you see that. Yeah. Let me show the screen to you. So, see, it's this one. Okay, you see that? So, refer to setting up a Hadoop cluster on CentOS. So, those guys who have worked on Linux, okay, they will find it very, very helpful. So, I have created this back somewhere in 13, I think. And I also have a cluster, okay, based on this. Have a look at this. I think for me, signal strength is weak. Yeah, could be. But just have a look at this particular PDF. Let me know if you have it open. Okay, so I'll get back in a minute, within a minute. Yeah, I'm writing it on the chat window. So once you open that, then you'll come to this screen. I'll get back in a minute. All right. So have you all opened this file, please? So I only have one answer from Ranjini. So see, we'll just shortly look into this file, okay, because we were discussing the distributed file systems. And in order to know how exactly a distributed file system works, okay, it is imperative to understand this particular, PDF. So see, this is a tutorial to set up a Hadoop 2.2 cluster on RHEL, right? Now, I'll just move into it. I won't be explaining each and everything because it is a tutorial and self-explanatory. And so I will just give you the instructions and directions on how you can, get ahead creating a multi-node Hadoop cluster. So uh, the first one here is, it is created on a physical machine like a laptop, okay, and with a workstation, VMware workstation, okay. So I prefer to work on VMware workstation rather than VirtualBox or others. So the basic setup that has been done is creating 3 virtual machines. Again, all the 3 virtual machines don't need to be created and cloned initially. We only have to create one virtual machine, okay, and then start by configuring, SE Linux, which is security enhanced Linux. We can disable that because SE Linux, causes interruptions in some services, and also disable firewall with IP tables, and then give the host name, IP addresses, and the MAC address. right? So once you are through with that, this will be the etc hosts file. Okay, those who have worked on Linux, they would understand that etc hosts is for name resolution. Okay, and then we would download the Java binaries. Okay, and then download the Hadoop binary from the Apache Hadoop.apache.org website. Okay, so these two are the basic prerequisites. Okay, so to install Hadoop, we require Java for sure. So for that itself is the Java configured here. Okay, then Hadoop happens to be, coming with four core configuration files. So those are the four core configuration files, okay, which are established over here, and ultimately, we get our HDFS, that is the Hadoop distributed file system. Now, there is a reason, for installing in 3 different virtual machines. It could have been done in one also, but the reason for installing 3 virtual machines, okay, I'll go back to the initial screen, okay, this one, and the reason for installing in 3 machines is to have a distributed file system. Now, we probably can make use of a drawing board, but anyhow, I'll just explain it through the help of this table itself. Considering each system has about 1 terabyte, so when the systems are distributed, okay, through over the network, then 1 terabyte would go in each of them, and we can say that it is an aggregated 3 terabyte distributed file system, right? So that demo I will probably give later on. So for now, at least, if you would like, you can go ahead, and install this complete system. So let's just have the 3 VMs running. I'll just turn off my Cloudera one, and so let me have a quick answer from you. Do you want to see the distributed file system? Huh? Okay, yes, from Pavan. So let's then go ahead and so see, from this PDF, I am now moving to sharing the VMware workstation. All right, and we'll start with the 3 virtual machines that have been created according to the PDF. So you should be able to see the screen now. Okay, so we'll just be looking at the VM. It's just pausing. Okay, it's just got started now. So let's see how many different types of DFS you can name. Name some DFSs. Let's see how many we can count. So I can say one is HDFS. Can you tell me which other DFSs are there? Okay. If you could expand that, it will be great. So by just GFS, so if you could just expand it, Manjunath. Google file system, perfectly okay. Any others? So let's hear from you which other distributed file systems are there. Come on. You have the liberty of Googling it. You can absolutely Google it as well. Different types of DFS. Yes, no, maybe. So I've asked the question on the chat window. Let me see uh, who can respond to that. None? Hmm? Okay. So, well, I'm not sure why only one answer, but uh, can we have a break for 15 minutes and get started? Sharath. So let's hear from you. Do we have a break for 15 minutes? Everyone, break for 15 minutes? So, Sai Jyoti, everyone is asking for that. So let's just break for about 10 to 15 minutes. I'll get back at 4:10. It's 4 o'clock now. Okay, I'm back now. So let's wait for others to connect and join. 4:15, another few minutes, we can again start. So are we all there? Shall we get started? Let me see your hands up. Raise your hands, those who are there. So we have majority, yes. I've seen a lot of you have also been very interactive, giving response. I'd asked the different types of distributed file systems, and we only have one response as of now. So let's see if you can tell about the name of distributed file systems. So we are going to start with one of the DFS just now, which is HDFS. Let's hear from you which all different distributed file systems are there. QFS. So I just got another response from Ramakrishna saying it is QFS. Pawan had earlier responded saying NFS. So well, NFS is not really a distributed file system. GFS, absolutely, yes, it is. But NFS, we doubt. Cloud store. Any others? Have you seen the Wikipedia page for DFS? Check out the Wikipedia page for distributed file system. Okay, so we are going to get started. All right, we are going to continue from where we left, and I'm getting some more responses. Cloud sir, are you sharing your screen? I can still see the Paul. Paul was actually. Okay, can see now. Fine enough. All right, so that's good enough. All right, so see now, depending on the PDF which we had last, all right, the PDF for setting up a distributed file system, setting up Hadoop, we have 3 virtual machines. On this left hand side, you should be able to see Hadoop name node, data node 1 and data node 2. All right, can you see that? Can you see that? The 3 virtual machines running? Yes, okay. Okay, great. Now see, these 3 virtual machines we had created by, installing uh, according to the PDF. According to the PDF, we have, installed the 3 virtual machines. So I'll also share, let me just see, you just refer to the virtual, to the PDF, only refer to the PDF for any jobs that I'm doing here, okay? If I show you the history, let's say history 10, so let's say the complete history. See here, if you see the complete history, you will see the same steps you see, which are mentioned in the PDF. Okay, the last step is start DFS. All right, we have 3 VMs running. A few things I'll ensure is the etc hosts file. So we can see that the this system on which I'm running, okay, is the 192.168.23.188. All right, and that is this machine, and its host name is name node. So I can do a host name, and see it's the name node, right? So which is mentioned in the etc hosts file, right? If you refer to the top of the PDF, you'll find that this is how we have the name resolution. Approximately, this is how the name resolution has been set, which means that if I do ping data node 1, uh, so that goes to ping the IP 89, okay, which is the data node 1. And if I ping data node 2, it's pinging the IP address 90, right? So at least so much is clear that we have a total of 3 virtual machines, okay, wherein Java has been configured and Hadoop has been configured according to the PDF. Further on, you can say Java hyphen version, and so this is 1.7.0 version, and then if I do Hadoop version, so that comes to be 2.2 version. Now let's come to the point of a distributed file system now. Yeah, with distributed file system, we'll see an interface, okay, let's say within this virtual machine. So I'm going to start this web browser within the VM. I can start it on my host VM also, that is imperative. You can start it anywhere. And here what we'll do is give name node and then a colon, and we'll say 50070. Okay, now this is not opening. Why? Because we haven't started the DFS, right? So when we do something like start DFS, so I'll have to do start dfs.sh. So see, start dfs.sh is a Hadoop service, okay, which is going to start some processes on this machine as well as on data node 1 and data node 2. Both these machines, it's going to start some processes. So we can say that these are inter-process communication processes, IPC based processes that are getting started. Let me know any doubt whatsoever you may have. So you had also been asking how much RAM should be there for Hadoop and CDH. So I'll run a command called as pre-tm, and it shows that the memory here is about 2 gigabytes. That's the swap and that's the total. So I've given about 2 gig to the VM itself and 222, which is because we have 3 similar cloned VMs running, so there will be a total of 6 gigabytes required for running this. Okay. Now that our start DFS has completed, all right, we'll just re-click this, and here we see that the name node, I can actually do one thing here. We can turn to the Unity mode. So actually Unity mode, starts. I hope you can still see this, right? Yeah. So in this we have df-h. Can you tell me what df-h will do? DF, guys who are into Linux, I'm talking to you. Great. Okay. So, well, yeah, file system size, usage. Okay. So that's more. So I've got the answers including usage and mount details. Absolutely. So do you see the screen? Because I've come to the Unity mode. I don't know if VMware is still showing the Unity mode. No. Okay. That's what. I had come to the Unity mode. So anyhow, now it should be visible. So now see, what does this display? As you've rightly answered that 367 gigabytes is for the slash mount, okay, and 935 megs is for, I think, the swap, and then some other for the boot. So see, this is the complete, complete file system size that had been provided. Yeah. So after starting the DFS, we have port number 50070. Okay. So I'll write it down also. Port number, which is standard. Okay. Port number 50070 for HDFS. So what you can do is just go to the name node, okay, and give 50070. This is also applicable to Cloudera CDH machines. Okay. Now, after going into this, we can do 2 things. One is to go to the file system, and the second is see the configuration, how your distributed file system has been configured. So because there are 3 virtual machines, we have 3 live nodes. Can you see this? 3 live nodes are there. So when I right click on this and opened it into the other tab, see there it shows what all are the different live nodes available for us. So it shows data node 1, data node 2 and name node, which is this itself, the one we are running, right? So now, how much was the disk available in each of these? We saw that approximately 367 gigabyte, isn't it, was provided to the virtual machine. And the same is also reported on the HDFS screen, saying that so much is the configured capacity of the local file system. So approximately 390 gigabytes we have per machine. And once you multiply this, okay, so we will have to do a 3 into 390 gigabytes. When you do a 3 into 390 gigabytes, we'll approximately get a 1.14 terabyte. So when you look at the overall cluster space, we see that the DFS, see the configured capacity is about 1.14 terabytes. Now this is the aggregate of all the three. Hadoop and other distributed file systems are linearly scalable. With linearly scalable, what we mean is you can always add or remove one server from the cluster. So considering that we have 3 machines as of now, we can go ahead adding the third, data node 3 into the existing cluster with this IP address and add a similar amount of capacity to it. Add another 390 gigabytes and make it almost 1.5 terabytes, right? So I hope this is clear now. Yeah. Please raise your hands or let me know if this concept has got clear. Configuring a distributed file system. Okay. I need to get your response. Do you still have any doubts? Because see, this is the very basic. This is a very basic scenario wherein we have 3 machines, all right? So you can think of your laptop itself, okay, which has, let's say, 500 gigabyte storage, and let's say your friend on the right and your friend on the left, they have similar, laptops. So we can think of a similar scenario where you have 500 gigabyte hard drive on your laptop and you have 3 of those. So multiply into 3 and resulting into a single large, uh, you know, uh, storage space of 1.5 terabytes. So that is the scenario over here that we have. Basically, it is like a grid. Okay, yes, indeed. Yes, good to hear from you. It's like a grid. It is precisely like a grid. I wanted to hear from you. And now that as you understand, it is like a grid. We come to the storage of the data over there. Okay, the data storage. Now note that HDFS is write once, read many. Okay, HDFS is read only, which means what? So then write once. I'm just writing on this write once and read many. Write once, read many has been a term, defined earlier, that you just write once, but you cannot overwrite. If I have a file in the HDFS, I just cannot overwrite. So I'm going to demonstrate that itself. Okay. So consider that we have a file over here. Okay. On the desktop with a utility called DD, I can actually create a bigger file. Let's say something like if equals to dev 0. and OF is equal to, let's say, big 1, block size equals to say 1 megs, and count equals to say 500. So you can make it 512. So I'm now going to create, a file which is about 500 megabytes, and you see it on the desktop itself. Okay, so this is the big 1 file. And now what we do is copy this into the HDFS, right? So we'll do a command called as HADOOP fs hyphen put. Put is to put from here to there. So there is the HDFS. Okay. So I'll say big 1, and where do I want to put? In the slash file system. So this is the slash file system. Okay. Slash has got just one file as of now. So when I do a hit enter, and let me just do a refresh there. See here, I'm going to do a refresh, and see there, big 1 is now getting copied. It's now getting copied, right? So because it's so big file, it's going to take some time to get copied, because it's now copying to the cluster. I hope you're following this. Yeah. So let's now refresh. Okay, so this has got copied now, and here the process has completed. So the size is about 512 megabytes, and now we go on to see the details about the file, all right? So say big 1, I'll click on this file because it was a file with all zeros. So there is not much of, meaningful content in that. It's all binary and can't be understood. And the way your DFS, okay, distributed file system, stores the files is in chunks, as one of you had said. So see, these are the nothing but the number of blocks. Okay, so each block is about 112 megabytes. And as you know that the file is 512 megabytes, it is divided into 4. This is a very, very important concept to understand. Now, in the HDFS, you may have noted something called as the replication factor. Okay, the replication factor. So the replication, it is because of the replication that the block is mirrored, or a replica of the block is created. Now if you see carefully, there is one replica created on 189 and other replica created on the 188. This is imperative to understand. There are two, we have one file, okay, big 1, but it is in two different, two different systems. Now, having replica in the DFS is for two reasons. Okay, I'll write the reasons down here. So why replica? Oops, I just so why DFS? Now the first answer to this is load balancing, and the second is your data redundancy. See, these two answers to DFS will clear off many doubts. Load balancing, think of YouTube, okay, or think of Facebook. When you have your files and data and stuff in Facebook and YouTube, there are many people who would be accessing them. Okay, so if you have, let's say, 3, 4, 5 such replicas on the DFS, then the server can render that, okay, as a service. Second is data redundancy, which is over here itself. Now, from these two, we understand that the data block is in 188 and 89, which means that any of the two nodes, okay, going down will ensure that your original data is still there, isn't it? So besides this particular file, we'll also have a look at the another file. Let me show you putting another file, let's say something like etc services into slash. So etc services is a small file, basic file, isn't it? It's a very basic file, etc services, and quite a small file. So it's just about 626 kilobytes. And when we look at it, it's very understandable. Okay, it's the same way, we also import databases. Let's say I want to import from Oracle or MySQL to HDFS. Same way it is done by using Scoop. So let me show you a very basic, test over here. That is to shut down any of these machines. Now, see, 188 and 189 are the blocks where services file has gone, and 188 and 189 was where the big file was there. So even before I shut down one machine, I'll show you how internal, storage is being done. So I just refresh this, and you would have noted that name node is 0.3 for, and data node 1 are both 0.13% full, whereas data node 2 is almost empty. There is hardly anything in data node 2. So what we'll do is we can go ahead, and shut down any of these two data nodes, and the resultant effect you will find over here. Over here we'll find the resultant effect that one of the data nodes has gone down. So let's go ahead and shut down the data node 1, right? Data node 1. I hope you can see this. The files are stored in name nodes itself or in slave nodes. That's a good question, Ranjini. The files are stored only in the data nodes or the slave nodes. Name nodes only store the metadata. Yeah, I hope this is clear. So let's just shut down the data node 1. Okay, so as you would have seen, right, I've gone off and shut down the name node 1. Right, so you can see that, right? The name node has been shut down. Now that it has been, even the replica copy is not stored. So I've got another question. Even the replica copy is not stored in the name node. No, the name node originally stores only metadata, but in our case, we have also used name node as a data node because we have limited resources. So name node has been put as with the role of a data node as well. So our name node is also serving as a data node, right? Internally, these are just processes. They are Java processes. Okay. So I hope I have cleared your doubts, Ranjini. Yeah, only for metadata. Yes. So next, yeah, we'll just refresh each of these, and let's just look at this one. So see, over here itself, we have seen that the data node 1, it's been 91 seconds since it has been in touch to with the name node. So are you there to answer my question? Oops. Neelkantha. Yeah, it is the mirror of data. Yes, it is the mirror of data. Yes, very much. It is a mirror, but you need to understand it is a mirror of what? It is a mirror of blocks. Now, let's go back to the HDFS itself, okay? In the HDFS, when you now look at, say, services, right? One of the nodes is down. We know one of the nodes is down. And if I'm referring to the services file, isn't it? It has to refer to the file. See, because the replication factor is 2. Replication factor 2 means it is a mirror, which means only one replica is created. When you have the replication factor as 3, then there are 2 replicas created apart from the original one. So it is all dependent on the replication factor. So I'll quickly show you where the replication factor is there. So we have Hadoop etc. And once you look at the file called as hdfs site.xml, okay, see there, this is the property of replication, dfs.replication. Yeah. Now, why this is being mentioned as 2? Suppose that you download Hadoop from, let me just show it here. I'll go to hadoop.org. Okay, let's say I'll go to this site and go ahead install downloading one Hadoop binary. So download Hadoop and you can just go ahead doing that. And once you run that, it will run out of the box also. Okay, it will run out of the box without any changes. But we need to do the changes to customize it, isn't it, according to the requirements. And the documentation is always available if you see the Hadoop Apache.org, okay, docs website. It's there on HDFS default. Let's say these are the 4 core configuration files I told you. So when you go to HDFS default, and let me search for replication here. Because we have very less. So I think DFS dot replication. DFS. Okay. Yeah. So see this one. So this is the DFS dot replication. I hope you can see this, which is 3 by default. So if we did not have the property explicitly set in this file, now this you will find in the PDF which I have shared. Okay, so DFS.replication, it was default is how much? Please write me on the chat window. How much is the default replication? No, it's not 2. Yeah, it's 3, Neelkantha. So the default replication is 3, which you have seen there. And for that reason, if I had not mentioned the DFS.replication to 2 or something else, I would have had 3 replicas, isn't it? The 3 replicas would have, been there. Now I'm coming back to one of the questions that you had. Could you please answer if the name node fails, then what will be the backup? If the name node fails, then what will be the backup? So that's a good question. Firstly, if the name node fails, okay, I'm just putting this back. What will be the backup? So one of you have asked this question. Pooja has asked this question. If the name node fails, what will be the backup? So I'm addressing this to everyone. The best answer is refer to Hadoop 1.x, 2.x, and now 3.x. See, 1.x never had name node high availability. Okay, so by high availability, as many of you would be knowing, yeah. So secondary name node is there although, but so standby name node was there in Hadoop 1x. Okay, name node high availability was never there in 1.x. 2.x has come with name node high availability, which also requires Zookeeper, okay, and certain other services. So yes, name node high availability is there in 2.x. Okay, I hope I have made this clear. Right. Okay. Now, so this was a DFS.replication. Okay. Let's now once refresh this, okay, and see the status. So I'm going to see the status once again. How many live nodes are there? See, it's actually requiring about half an hour. About half an hour it requires to be shut down, and then it will start re-replicating. So what will happen eventually now is that after half an hour, if our data node will not come back in service, then the data that this node had will start getting replicated to this node, data node 2. So you will soon see that that happens. So do we need to create a separate server for HA, or what's mechanism of recovery if it fails name node? Okay, now so see, name node HA is in Hadoop 2.x. So I'll just look at the Cloudera website, okay, and give you a reference from that, so that you can also, have a look at it. Okay, will that be fine? So for now, name node HA is okay. So for now, we only had our, HDFS and the distributed file system. Apart from this, we also have what is called as the where is the library? Customize the library data size. Now we just need to look at. Now, see, this is the second scenario which I had in mind, the cluster FS. Probably, yeah, this can also be, we can see that a bit later on. So this is a cluster which is also termed as a distributed file system. So I still don't have, which all are the distributed file systems available. GFS, yes, you said GFS is one of them. What others? So have you come across something called as Moose FS or Luster FS? So let's move on, and let me just show that to you. So I'll shift back to the PPT. Okay. So it was very essential that we moved to this place and saw the distributed file system, and then moved on. So the Hadoop and MapReduce architecture. I hope you can see, all of you. I hope all of you can see this. Yeah? Yes, no, maybe? Okay. Okay, we see about few hands up. This is Hadoop 1x architecture. Yes, that's right. Yes, this is 1x. Okay, so going back to the Hadoop and MapReduce architecture, yeah, Hadoop is quite common architecture, 1x and 2x. There have been substantial difference, but architecturally it has been still the same. It's a master-slave relationship. It's a client-server architecture basically. But then yes, we call it as distributed computing, even though it is client-server. This is why I would strongly suggest you to also look at other distributed file system architectures, okay, like ClusterFS, Ceph, okay, and several are there. But the important ones where you can have use cases for your projects. So for Hadoop and MapReduce, okay, the one that we saw as the name node, that was the master node, okay, and on the slave nodes or the data nodes were our data node 1, 2, and 3, right? So they are basically in a network, right? And when it comes to very large networks, so they are rather Google kind of networks or Facebook. I'll share with you a table, okay, which has the top Hadoop clusters, okay. So it's only Hadoop clusters, not the other DFS. So supercomputing clusters are the other types that are very huge clusters. Okay, so the way MapReduce works here is your master node happens to collaborate with all the slave nodes as soon as we have a job started. Now with a job we can think of as a program. Now this is the basic difference between a local and a distributed or MapReduce program or a parallel program. Okay, you have to distinguish between the two. A local is like your Windows application, okay, like Chrome or Mozilla web browser or MS Word application. These are local and they are uh, compiled for local computations, right? Parallel application or distributed is because we have data segregated in several places. So as you see the data nodes, just 3 over here, there can be 300 data nodes. And all the 300 data nodes constituting different data pieces, as we have just seen. So when we go for the computation, the data has to be gathered from different locations, from several locations. The data has to be gathered from these different locations and then computation done on the master node. So, well, I probably said it wrongly. The computation is not done on the master node. Hadoop's philosophy is not to get the data from a source, but to bring computation to where the data lives. So, although the computation will start or the process will start on this is called as the resource manager. Okay, it will start here, then it will spawn it to several slave nodes. It will say that okay, it has to spawn to these 3 nodes or these 2 nodes or these 5 nodes or these 10 nodes. So that is the responsibility of a resource manager. Now, this is a bigger uh, uh, real world Hadoop infra. If you would like to see another, I'm writing down. It's called as Oracle Big Data Appliance. Now, if you Google Oracle's Big Data Appliance, it constitutes just similar of these 4 servers. Okay, it's a starter rack. Oracle will provide you with a full rack. First 2 nodes are name nodes, okay, and then the next 2 nodes are the data nodes in Oracle Big Data Appliance. However, the image that we are looking at, this is another real world situation, and it's sample Hadoop cluster config where we have one name node, okay, and the secondary name node, and these 8 of these are the data nodes. So you can see these are the servers and 8 core CPUs, okay, 64 gig memory and 12 into 3 terabytes hard drives are there. So how much is the aggregate we are getting? 12 into 3 terabytes, 36 TB is in one, in one server. So you just multiply 36 into 8. 36 into 8. How much does that give? Around 288. About 288 terabytes, isn't it? 288 terabytes you are getting. What's the difference between secondary name node and passive name node? So it's not the difference between secondary and passive. It is the difference between name node and secondary name node. We also call the secondary name node as a passive name node sometimes because it is not active. Active in the sense it is not in production, isn't it? So now what happens is, just to tell you about the high availability part, the name node, when you keep, when you start, and the secondary, as I said, it is only holding the metadata. Now see, the metadata is the file name. If you see the, basically the, like a local file system, okay, C drive or D drive metadata. Let's say if I want to refer to something like my document, or let's say XYZ presentation. When I write XYZ, it will see what is the header. Where is the header, and it will just refer to that header. Same thing in name node also. If I say that I want to fetch this 1 gigabyte video file, it only knows the name of the file and the block locations of that file. The actual blocks are located into the servers. So with the name, it just goes on to fetch the different data locations, okay, block locations, and then provides back that video or let's say a data file. So this is what is constituting the, does it sense passive name node? What is that? So Ramakrishna is again asking, does it sense the passive name node will be active only in HA cases? Precisely. So precisely, it will be active only in HA cases when the main server fails. So example in Hadoop 1x, it was not a plain failover. If your primary name node fails, it did not switch over to the secondary. You had to reboot the secondary. That is how the situation was. But with Hadoop 2x, yes, if the first fails, it switches to the second without any interruption. So it's seamless, almost seamless. Now how does this happen? The secondary name node keeps on fetching the metadata in its locations from the primary name node. So it keeps on fetching, keeps on fetching, keeps on fetching. Every hour, once it is going to fetch, or so many read write happen, it will fetch. Anything greater, lesser, it will fetch. Okay, the secondary name node, and that is how it ensures that the name, the metadata is replicated. And then, in case of a failover, then the first one fails. It fails to the second. I can show this failover to you because I have the simulated failover with me. But we'll need some time to demonstrate. Let me know if you like to see the demonstration for this. Yeah. So that's the name node high availability. Data node high availability is already there. As I mentioned that we are starting with replicas, isn't it? So if you have 2 replica or more, so 2 replica means replication factor equals to 2 means you will have 2 blocks of the same data. So considering that this aggregate capacity went to 288 terabytes, we'll be able to store 144 terabytes with the replication factor of 2, but not more than that. Yeah. So fine, I'll get that in the next session. I'll get the high availability in the next session and we'll demonstrate. So the HDFS high availability is obviously there with us. Right? These switches are as such kept for redundancy because we have hardware level redundancy here in case a switch fails, and then you have the public facing network after that. So the companies which are using Hadoop include Facebook, Yahoo, Amazon, eBay. So these are the different number of companies which are having, so IBM is also a provider of Hadoop. The company list has actually gone up. So I will also make a note of the list of Hadoop clusters, list of top Hadoop, so that we can see that in the next session again. So when you compare now when we compare Hadoop with some other systems like relational databases, right? So relational databases comes as one of the comparison points. Between 80 to 90, rise of relational, okay, and from 2000 onwards, we have seen a relational dominance. And then we have what is called as NoSQL databases. So let me know if you have worked with any NoSQL. Any NoSQL anyone has worked with? HBase. Okay, none others. So we have one answer. Okay, Mongo. Okay, MongoDB. Then, all right, fair enough. So see, NoSQL databases is started with kind of a joke, there was a conference in Europe, and the moment this conference was being held, the organizer sent a request, to all his colleagues and peers, saying, "Hey, let's talk about NoSQL in the conference." Now he got a astonishing response from the members saying that, hey, SQL technology and structured query language is our bread and butter and things like that. Why are you saying that we are having NoSQL now? I mean, this was like a joke, that he happened to perceive, and then he clarified that, hey guys, I'm not mentioning no SQL means literally no SQL at all. By this, I mean to say that let's talk about not only SQL, because the world seems to be moving, way now beyond uh, the traditional SQL. So this is how it started, okay, and there's been a lot of work that has gone into NoSQL. So precisely when we look at NoSQL, uh, there have been about 5 basic categories of NoSQL databases. So these happen to be column N family, then Cassandra, HBase, React, Redis. Okay, and so these are the ones. So these are the column. These are the different families: 1, 2, 3, and 4. So there is one column N family. Okay, so where you have HBase and Cassandra. So, for example, one of you have worked on HBase. So HBase was created for as more of a columnar database, and having multiple rows and columns within that. So it has been created for millions of rows and billions of columns, or probably the vice versa, because it's more of column oriented. You will see when you create tables in HBase, they are being created in a column way. So it's good to understand HBase, okay, and because HBase and Cassandra are kind of neck to neck, and they are both column N family databases. So Google's Big Table is also column N family. If you see Google Big Table, that is also column N family, and there is this PDF that I have shared with you on Google Architecture. Have you gone through it? Anyone? Google Architecture PDF? Guys, Google Architecture? Okay, so have a look at that, and you'll see a mention of the Google Big Table in that. Then we have a key value store, okay, where React, Redis, and Project Voldemort comes. Then you have the graph database, okay. So graph is more of representing relationships in the graphs. And then you have document databases, which includes Mongo or CouchDB. Right, so these are the different document stores. It's like a document store. So for a document store, unlike any relational database, where we make a structure. So rather than a structured database, you can put almost anything in the MongoDB. Okay, so that's a leniency of MongoDB. So these are the different, NoSQL databases that are available to you. So I hope I've made myself clear on the NoSQL. Okay, so now there is other comparison between RDBMS and Hadoop. Okay, so this may not be a precise comparison point, but still we do compare, because RDBMS and Hadoop are quite different. So, for example, multiple gigabytes can be stored in RDBMS. If you want to store, can you store pictures in MongoDB? Absolutely. You can store anything in MongoDB. All you need to do is just create a kind of a see, to store also we have to make a structure, right? So for storing pictures also, we have to make a kind of a structure, okay, and like a JSON or BSON, binary storage object notation. in that we have to mention that this is the path of the particular picture. So yes, MongoDB can absolutely hold documents as you can define it as a picture. Okay. Yeah. So Hadoop happens to scale to multiple petabytes. Okay. As I said that it's linearly scalable, then accessing it is interactive, isn't it? Traditional RDBMS is interactive. So with interactive system, you can, it's like your any relational system which is doing a transaction processing, isn't it? You can do insert, update, isn't it? Delete, these kind of things you can do on this thing on RDBMS, but it's not so in Hadoop. Okay, although some applications do, like NoSQL, they do work on Hadoop, but it's a different way. It's not much of interactive way. It's batch updates, write many times, whereas Hadoop is read once. So write once. I mean, if I go back to our VM, okay, and if I rewrite the same file, it will not allow. If you would like to see that, let me just show that for a moment. We'll change the sharing to the VMware, and we'll go back and try to rewrite the same file. Okay, so consider that I have to just put big data big one again in the same location. Now we know that this file is already there, isn't it? If I go to browse file system, see the file is already there, right? And see there it says unable, that is okay, but see no such file or directory. Okay, hold on. So once again undo. See, file exists. So when something like this happens, then what you have to do is, what do you have to do? Delete the file. You got to delete the file and then put it again. So I'll show it for the other one, services, let's say. See, their file exists. So what I'll do is Hadoop fs and remove it, delete it, rm. rm services. So now that this has got deleted, I'll refresh. See, the services is not there anymore, and once again put the file there. Yeah, I think you have a question. So how do other applications interact with data in Hadoop? Okay, that's a good one. How do other application interact with data? So it's REST API. It's mainly the REST API. Okay. Apart from REST API, it provides two other protocols. It's called as Web HDFS and HTTPFS. And you can also use Fuse 3G. You can Google these, okay? There are different methods of having. So his question was, how do other applications, but broadly, see, broadly it is just the, broadly it happens to be, REST API. Okay, let's move on into this one. So we had discussed these. Yeah. So we were here. I hope you can see this. Right. So it's write once. You cannot just overwrite it, because you cannot. That's the property of HDFS. Right. Structure, it is static schema. Whenever we are starting with relational, we first write the schema, okay, and then put the data in it. However, it's kind of opposite here. You can start putting the data, start looking at data, and then think of applications and develop the applications. Scaling, I have just said non-linear, whereas Hadoop is very much linear. And your query time is normally immediate, whereas Hadoop has a lot of latency. Yes, that's no doubt about that. Okay. So we talked about unstructured data, right? And the features of unstructured data. So it does not reside in traditional databases. So what is this? Is the same copy will be stored across nodes, which mentioned in etc host file. No, that etc host file is just in the HDFS. So, well, the same copy is stored across only the node where based on the replication. So, see, we have a question here where you happen to ask, is the same copy will be stored across nodes, which is mentioned in etc hosts. So see, etc host is obviously one of the required things in Linux. But what is stored in your nodes depends on the number of replica. Okay, so if replication factor is 2, then I will have exactly the same copy of one data item. So let's say I have a file of 10 gigabytes. Okay. Now this 10 gigabytes, when it is getting stored on one data node, it will be replicated to the second data node. The complete 10 gigabytes will be replicated to the second data node. How Hadoop will communicate each other nodes for same copy. So that is Java processes. So how will Hadoop communicate with each other nodes? See, when we do start DFS, with start DFS, there is a Java process, that is starting in each of the servers. So I think I'll have to switch back again to this. So we'll shortly look at it. See, when you do JPS here, okay. So see the data node working. Then I'll go to the second thing, and I'll SSH to data node 2. All right. And now it is in the data node 2. There also, when we do JPS, see, that's a data node running. Now suppose I do stop -dfs.sh. Consider for now that we are doing stop DFS. So if I keep on doing watch JPS here, the data node process will stop by the instruction of the name node, and vice versa. So see, it is stopped over here, and when the data node stops, since if I assume that you know Linux, even this is a Windows command, so I'll run netstat-an, which is network statistics, and then I'll grep for 50070. see this port number is also gone. So basically our entire Hadoop cluster has gone. So we'll again do a start. We'll do start, and you can see what JPS on data node 2. See there now data node 2, the process called as data node has started. The process over here would also have started. Got it now. Okay. Default replica. Okay. Okay. Yeah. I'll be happy to explain this. See, this is basically from the same PDF which I have shared with you. See, as soon as we start the JPS, okay, start DFS, right? Now, start DFS, you can further see where is it and what all it is having. It's a script, okay? It's a script having certain stuff, to start. So broadly, you will see it's starting off the Java processes internally. So it's the start DFS script I'm talking of, okay? Only after we do start DFS, okay, we have a distributed file system started. So one of you have asked, please explain. So based on the same PDF, okay, yeah, that's why I would suggest you go through the PDF. When we do start DFS, it has started this distributed file system, and internally it has started the data node process. Okay, there is a file in Hadoop, okay, Hadoop configuration to be precise, which mentions the slaves. So I'll show you. That is the it is the etc slaves. See, this is the file which mentions where all which all are your slave nodes. Okay, so this refers to all of our slave nodes. So that is how as soon as I do start DFS, okay, it's going to start the process called as data node. The data node has been started. Now, this system, this machine itself is working as the name node. So since this is as the name node, it is starting a name node process for itself, right? So the name node is started as a process for itself, and it will tell, if you would have noted, see, I'm on the name node now, and when I do SSH to data node 2, right? Does it ask for a password? It doesn't ask for a password. So it's called as passwordless authentication through SSH. I'm sure those who have worked would be knowing this. So without asking the password, it's gone. And through this mechanism only, it's starting the processes on other systems. So when we look at JPS here, the data node is started here. Data node and the name node are communicating always. So data node, all the data nodes are pinging or are telling the name node every 3 seconds that they are alive. So this data node will tell this that it is alive. Every 3 seconds it will tell. So let me just refresh this now, and see there, now you only have 2 nodes, right? And you look at the dead nodes. So this was the name node. Live nodes now only 2 of them, na? And the live node, I mean data node 1 has gone out. So once again we can refer to this and also get the other started. So as soon as I start the data node 1, we should be having it up and running. So I think we came here into this to check for the data nodes based on the query that you had. Okay, I switched to this one. So I hope you have got this. And as I said that every 3 seconds each data node is pinging, or it is telling the status to the name node. That's what we'll find over here. Right? If you see over here, see last contact, it's 1 second or 2 seconds. Okay, and the other data node was about 90 seconds. So that's how it works. So let the other data node start, then probably once again I'll switch back to this one. Okay, so I hope this is clear now, Neelkanta. All right. Okay, now the unstructured data, all right, happens to be anything that is not included in the traditional databases, right? This one. So it can have any internal structure, okay, generated by both humans and machines, okay, textual as well as multimedia, M2M, machine to machine. So these are some of the examples. Personal messaging, okay, which includes email and instant messages. So you were asking about what is the limitation for replica? Well, see, there is no limitation. There is no limitation as such for the replica. Okay, you can have say even 200, but it is more clear on the in the docs, isn't it? If you refer to the docs, then you will find that. Let me show that to you. 1 second. Default is used if the replication is not specified the creation time. See, there is no default replication as such, all right, but it's going to be a problem point. Okay, so that's what I'm referring to. It can become a problem point later on because uh, uh, if you go on increasing the replication factor to 200, let's say, okay, say you have 300 nodes in the cluster. So the 300 nodes, out of the 300, 200 nodes will be just replicating to each other. It's going to add on the overhead, right? So the overhead will become too much. That is not the problem point. Problem point is the bottleneck that the name node always uh, overcomes. Sorry, the name node always comes across. So name node is the bottleneck. Let's say that we have a Hadoop cluster, okay, of say 100 data nodes. So you have 100 data nodes with multiple terabytes, maybe petabytes of data. But you have only one name node and a resource manager. The entry point is only one. So if entry point is one, and then you have many number of MapReduce jobs and many number of clients, okay, who are have accessing many clients and many MapReduce jobs. So the overhead will be there on the name node, that single only node. So what you do in that case? So can you tell me? I think the audience is a lot quiet. Let me hear from you. What do we do when MapReduce and the resource manager has an overhead? Anyone? Can you repeat this? Okay. No. What I mean is, see, this is the main problem in the Hadoop clusters itself. Many of you have asked about name node. All right. So name node uh, high availability, and then resource manager high availability, and things like that. What if the only name node that we have, okay, is getting 1,000 requests per day, or rather per hour, whereas it can handle only about 200? Then what do you do? We can do clustering unlike RDBMS. So I have just wrote it down on the chat window also. Multiple name nodes, precisely. So we go for multiple name nodes, and that is called as, which is called as federation. So if we once again look at the documentation page of Apache, okay, you will find federation over there, Hadoop federation. So in this scenario, what we do is we have 4 different name nodes serving 4 different regions. You have a single HDFS, okay? HDFS is single. Let me just look for a drawing area. I'll rather draw and explain. Okay, so in this scenario, what happens is, let me just open paintbrush, okay, and I'll MS Paint and explain it there. Okay, now see, I have the MS Paint open. I'll just be explaining you how this happens. So what we will have is, let's say that this is the name node, okay? So what you call, that's the name node. So that's okay. Now see, if we say this is NN1, oops. Okay, this is name node 1, let's say. Right, this is name node 1, and let's say it is having, okay, let's take this box as the HDFS. So you have the HDFS over here. Now, the work that we are doing with this HDFS, this is what is the main, trouble point. Name node 1 is having too much of an IO. So the IO is not just from here, the input-output request can also come from the clients, right? Okay, I hope you can see this. Now, in this scenario, what we do is we'll say, okay, go ahead for another name node 2, and then another, name node 3. So, and maybe another name node 4 also is possible. So, but still, they both will be accessing the same HDFS, whereas only the regions will be different. So, we will say that this guy is now looking at the east region, and this guy is looking at the west. So east, okay, west, and that way. So that is how, right, the federation works. So this is the example of federation. I hope this is clear, right? I hope this would have got clear. Okay, great. So that is a very common scenario, okay, because the name nodes are normally subject to either failure, okay, or too many of requests in such clusters. Okay, so I think you should be able to see this now, and all right. So we'll move on into where we left, and so unstructured data, right? Could be anything other than okay, other than our regular. Let me see if you have any further questions. Name nodes can interact with each other. Yes, that's true. So in federation, they have to. Name nodes, yes. Okay. So moving up to objectives and benefits. So yeah, these are some very basic slides. Okay. What's driving the big data market? It's business intelligence, okay, and predictive analytics and data mining. So traditionally, we had ad hoc querying, reporting, data mining techniques, structured, small. So this was previously there, but now, yes, the industry has moved on. So see, this was more on fundamentals. I think now you would have got much clarity, right, on the big data fundamentals. So value of big data analytics is more real-time in nature than traditional data warehousing applications. So as per the graph, you can see, isn't it, that the data warehousing are more kind of non-real time, whereas big data applications happen to be real-time applications. Okay. Shared nothing, massively parallel processing scale-out architectures. So I still haven't got much of the responses, okay, on this DFS that I had asked. So anyhow, we are reaching the different distributed file systems. See, this is one of the real world scenarios wherein your boss comes and says, here are 50 gigabytes of log files. Find a way to improve our business. Isn't it quite funny? I mean, if you are into a job which says that you have to do analytics. Okay, you have been hired to apply your mind with some programming language, be it Python or R or any programming language. Okay, because each one of us, during our academics, whether graduation like BSc or BA, BCom or BTech engineering or MTech or MCA, we all usually go through, understanding some or the other programming language. So that's this, scenario. I mean, your boss comes and says, "Hey, this is 50 gig of log file." What would you really do? I mean, in that, what would you do? See, at least what I would do is try to find patterns. Okay, finding patterns in data is the trick. One of the tricks, I must say. Okay, because it's 50 gigabyte of log files. You have to find what is the commonality in that. Right. So that is a pattern we have to, identify and then present it to your boss. What else can you do with the 50 gigabyte of log files? Tell me. Can you hear me? I hope I can. Okay, great. So, have you come across something called as natural language processing? Go with timestamp. Okay, that is one of the things. Yes, that is true. Have you heard of natural NLP? Isn't it? It's termed as NLP. So the log files, isn't it, would contain some words. So we have to make some algorithms that are that we have to program with, right? Something live streaming? Not exactly. I'm not talking of live streaming. I'm talking of 50 gigabyte of log files. So I'm again writing down the logs come from where? Databases, applications, web servers, web or application, isn't it? These are the sources of log files. There are many other places where you get the log files from, isn't it? So this is typically we are talking of a web application, isn't it? Web application, one of you have sent the timestamp. Yeah. So Renan is getting the audio disconnected. I don't know why, Renan, but it seems not a problem as such. So see, this is one of the typical scenarios, okay, which is surfaced previously. And these days, if not an individual, at least teams are, put across a similar challenge that, they have such and such log files and we have only the data to which we can play with. So how do you do something better to do, improve the business? So use big data to make better decisions. So see, big data, we have done the core part of it, more of core, isn't it? Or maybe the tip of the iceberg. Okay, the right, that's the right thing to say. Is that you have only done the tip of the iceberg. The majority of it is underneath, isn't it? Have you seen the iceberg? It's only about 10 to 20% which is floating outside. The majority of it is inside the water. So we have basically done what big data comprises of, or how you can get started with big data, and more of it is all programming. Okay, and then whether it be Hadoop or you're programming in C, C++, and then there are tools, several tools that are fitting in. So Public Data Explorer is from Google. See, this is one of the very fine visualization tools. What Google has done through this is, they have got different data sets, okay, from over the world, and those data sets are either in Google or it is in the original location. So what Google has done is, using the Google API, they have given the visualization. So I would be rather happy if I could, share the same over the web browser. So let me just show that. I'll share my web browser application and start the Google Public Data Explorer there. Okay, so I've just shared this, and this happens to be one of the very finest things to see. If we look at the dots over here, it will show the different types of data, and if you look at the one below, it shows where it has got the source from. Okay, the data source, let's say for WDI, it's World Development Indicators, comes from World Bank. Okay, so when I click on this, it will actually take me to the World Development, World that particular website, and same for several others. So see there, see data from World Bank. So when I click here, I think it's going to worldbank.org. So this is precisely, okay, where Google has sourced all the data from. And then you can always do a animated view. When I click on this, it's going to show an animated view of the entire thing. Let's say if I now this is what government debt in Europe, okay? Or let me show you something more meaningful. So let's go for okay, life expectancy, and okay, we can see this, explore the data. That's energy production. And see, this is mainly providing you how much of energy production is happening. So let's say if we click on Alabama over here, and so that's a good view, so you can see trillion BTU. So BTU happens to be the British thermal unit, okay, and same goes for this one. It says that I can't see the legend. So the blue line is for coal, okay, and then this one, orange, is for the nuclear energy. So which means that the coal has been on the increase and nuclear energy has been on the increase as well, whereas natural gas has been on the decline. So similarly, we can also do see the first one, and see the first one, it shows life expectancy where and on the y-axis. So for each of the countries, it is showing in a animated view how much. So see, this is basically from the World Bank data that Google has sourced, and it is showing the visualization. So I'll come back to our show. Okay, and that was the Public Data Explorer. So we'll look at the distributed file systems. Okay, so what is a distributed file systems? I had asked you this thing previously, isn't it? That what is a distributed file system? And I only got GFS as the answer. So a distributed file system is any file system that allows access to files from multiple hosts, right? Multiple hosts. So one of you said NFS, so which NFS is not really a distributed file system. GFS, yes, because GFS will be, let's say, 1,000 machines, and in each of the 1,000 machines there is data storage as well as processing. Same goes for HDFS also, where there is data storage as well as processing. Okay, this makes possible for multiple users on multiple machines to share files and storage resources. DFS differs in their performance, mutability, okay, of content, handling of concurrent writes, handling of permanent or temporary loss of nodes or storage, and their policy of storing the data. So see, these are the different, yeah. Anyone had a question? SharePoint is not distributed, okay. SharePoint is an application, and so it's a server application, Microsoft SharePoint. Although I've not worked much on it, but yes, I do know that it can store and it can be used for storing a lot of data and for sharing. So a couple of companies I've seen, they hold and store the data in SharePoint. So we are talking of distributed file system. So one that we precisely saw for HDFS just now, and we also have Cluster.fs. So I can show you Cluster.fs is also there on one of my virtual machines. Ceph is there. So these are some of the distributed file systems which you can actually install and configure for yourself, or maybe for a project that you are working on. So Lustre has been there for supercomputing file system. Lustre is for supercomputing system. MooseFS as well is very similar to HDFS that we have seen. Okay, so this is a comparison of different file systems, and as you can see, you have Ceph, okay, BGFS, Cluster, which I said, Infinite, Objective-FS, MooseFS, and so forth. So I'm just counting the important ones. The Lustre, see, many of them are written in C language and C and C++ languages. So, and lastly, you also see the HDFS, which is written in Java. So, in order to work on any big data system, okay, we will have anything more than 10, server machines connected to make a file system, which can be any of these. So I hope that was clear to you, that file system, okay, anyhow will be comprising of these, right? So I think we are now nearing the completion of today's session, and we are almost towards the end of this, and you do have a session tomorrow also. So I'm just going to share once again our original day one session content, so that we can once reiterate and just revise on the learning. Okay, so I'm sharing this. Is big data mainly used in the area where there is more unstructured data? Well, that's a good question. The present trend happens to be going that way. So that's a very fine question. So yes, but traditionally, at least in the last 5 years or so, big data has not really been into anything or much of related to unstructured. Why? Because the structured data itself was too much in content. So the organizations are still, some of them are still struggling to to do better and better projects on their structured data itself. So the unstructured data in any case has to be first put into structure. Okay, so that's an important point to consider. So I'm just writing down unstructured data too has to be put into a structure first, right? Or another way of putting is consider the Google Content ID. Now, although we have video files there on the YouTube, but then what Google is doing, it has already put one frame by frame, okay, and put it into a database. So when the new videos are uploaded, it is still matching each frame. So yes, that's a very good question, I must say. So organizations are in fact moving towards that. Many are looking at call center, records, then medical records, genome sequences. So these things, companies are already moving towards. So that's a good question. I appreciate that. Any other questions you have for today? Because we are already running out. Could you please explain a bit of security of data? Okay, so I'll put this to tomorrow's session. Tomorrow we have the same the session at between 2 to 6. So I'll be covering cluster.fs as another file system, and we'll be taking up the name node high availability. So these are the things I'll cover apart from, yes, tomorrow's contents. So my mail ID to send the questions after the session. Okay, so I'm just writing it down. Please mail me at this. And so I hope all of you have enjoyed the session today, and we look forward to meet you tomorrow. Let me have your okay, hands are okay. Yeah, you're welcome. Sure, most welcome. You can have a look at the material that I have shared, okay, and in the meantime I'll have more of stuff prepared for tomorrow. Thanks everyone. Have a good day. Good night.
you.